Hello, Tacoma.
Hi, fifth graders.
Welcome back. We have a fun lesson today.
I'm really excited about this.
I'm going to learn a lot.
Oh, yes.
Before we get going, though, let's check in with our zones. What zone are you in today? How are you feeling? Blue, green, yellow, red? That means I'm ready.
How are you feeling, Mrs. Wally?
I'm in the green zone.
Me too.
You are?
Yeah, I'm calm.
Ooh.
I had a rough morning.
I'm so glad you're back in the green zone.
Do you know what helped?
What?
Really focusing on the work that we're doing.
Yes.
And taking lots of deep breaths.
I think sometimes when you're not in the green zone, getting focused on the work can help get you there.
Yep.
Mr. Kevin, how are you feeling today?
Still in the yellow to green zone. Mm-hmm. I too am focused on our job. It's a great job.
It is a great
Wonderful
job.
to work with you. But you know, there's always those unknowns, question marks
are.
floating out.
Hopefully soon the unknowns will be gone.
Yes.
Yes.
All right, friends, let's get going in our work today.
3
Okay.
personal standards.
Today and every day.
We agree to
Show respect, make good decisions, and solve problems. And one of those ways we're showing respect is by holding space every single lesson to honor our indigenous land and people.
And how we do this is by looking outside our window. Look at the sky, look at the trees, look at your surroundings. Our physical space stands on the ancestral and historical lands of the Puyallup tribe of Indians. We acknowledge the Puyallup tribe of Indians, their community, their elders, both past and present, as well as future generations. We make this acknowledgement as part of our work to dismantle the ongoing legacies of settler colonialism and unjust treatment. So when we say that we hold the space, we've been talking about that in all of our lessons.
Holding space.
Holding space.
What does that mean? Fifth graders, what do you think that means? Take just a second. What do you think we mean by holding space? What do you think, Miss Oslin?
I think it means, and it's interesting that this is connected to our zones, that we have a lot of unknowns and feelings that we're having pertaining to things happening at home, things happening at work or school, or how our physical body is feeling.
With our friends.
With our friends. And just pausing all of that
Yep.
to think about
This. So we're saying this is important, but for these few minutes, this is what's important.
kind of that term that we've used, getting out of our own head.
Yeah.
Stop thinking
pausing
about
it.
me.
Right. And take a few moments to think about someone else and how they want to be treated.
So it all relates to
The platinum rule.
platinum rule.
It is a good one,
It is.
but it's not easy
No, it's not, especially when we're so busy.
and have a lot of feelings and have our own experiences.
Ooh, isn't it hard when like our experiences are challenged?
Or our thoughts are challenged and we take it personally.
We've experienced that a lot this week.
Oh, yes. But you know what? We're better because of it.
That we are. All right, we're going to review our scientific process.
Okay. What is our scientific process?
This is how science works.
Oh my goodness. We start by, I notice something, and we make observations,
Ask questions.
share ideas and data that we've collected, and read.
Read.
A lot of reading about science discoveries. We read and we read and we read some more.
And sometimes we watch and listen. And then read some more.
And then we take that knowledge and move to the next phase, which can be this one or it could be another one. You don't have to go to this one, but this is where you typically go,
Yes.
which is you start to come up with an explanation. Then you conduct experiments and take some of that reading you did and gather the data.
And this also might be where you change your thinking. I thought this based on my experiences. I saw this. Now I think this.
And you might have to revise, which is what you were just talking about.
Yep.
And then you can start to draw some conclusions. you can start to say, oh, so that's why that happens. Or, oh, well, now that I know that that's a problem, how can I engineer a solution to that problem?
Or,
And then you're going to get more questions.
I was just going to say, once you learn more about something, it's like, okay, well, now I think I know this. How does that explain this?
Or you might think, I did it. I figured it out. But then you need to check with others around you and see if they found the same thing and see if they can recreate what you thought and what you did and get the same result. And
called
repeat it
repeating.
again. Listening to their feedback, reviewing each other's feedback and ideas, and coming up with new questions and ideas, which then sends you right back to the top to
Which
have
is
more questions.
a great feeling that we don't ever have to think we know everything.
That's why I love science.
Are you ready for this
It's so
phenomenon? Here we go.
good. Mr. Kevin, I am so excited for you to watch this one.
Oh, cool.
Just you wait.
I'm looking forward to it.
It's pretty amazing. I found it, was like, oh yes, this is amazing. We need to. Oh. Are you ready,
Okay.
Mr. Kevin?
Yeah, here we go.
Okay, here we go.
What?
What is going on there? Miss Awesome, what are we seeing?
I don't know.
It looks like a piece of metal,
I think it's copper.
and then there's this like tube around it, and it's like moving it around, and then it falls and splats on the ground.
It changes from, I think it changes from a solid to a liquid.
But it doesn't touch anything. How is that copper thing able to make that melt?
I don't know.
I wonder if it was through thermal transfer of heat.
Ooh, that's a nice word.
Well, that's what we're learning about today.
Yeah, it is.
Pretty cool, huh?
That's neat.
I would love to see that in person. I bet down at the Brad King plant we could watch that happen in person.
I bet.
That would be a cool place to go on a field trip, talk about heat transfer. All right, friends.
Our essential question. How do different forms of energy influence a region's economy? Now, we're not going to answer all that
No,
big question.
we're just going to
today.
do one little part today.
We're going to focus on heat energy today.
We kind of went through all the different kinds,
We did.
and now we're going to zoom in on heat.
We are.
Okay.
Let's review.
Our big science word.
Fifth graders, we know it's silly, but we hope you do it with us. Economy.
That's how money is made in a particular region.
And used.
Oh, and used, yes.
Energy is the power or ability to make something work or be active. And in order to make money, we have to work and be active, which means we have to have some kind of energy that was potential and then becomes kinetic.
Yes. We're going to learn about infrared.
Infrared.
That's a tricky word to say.
Infrared?
Infrared.
Well, I think it's red.
Something with red.
Something in that's red.
I said heat because I feel like I've heard this word related to heat before.
Well, I have this foot massager and it has infrared heat on it.
Ooh.
And when I put my feet in there, it's warm, but there's no heater inside.
That reminds me of our phenomenon. How does it get hot then if there's no heater inside?
Yeah, exactly. What is the final meaning, Miss Oslin?
Are we ready for some really big words?
We can do it. We're fifth graders.
Invisible electromagnetic radiation next to and longer than those of the visible red end of the spectrum. Okay.
Basically, it's a type of heat that uses the far end of the red color spectrum
Yep.
and uses electromagnetism and radiation to produce heat.
And you can't see it.
Nope, couldn't really feel it. It's also used to measure heat.
Yes. The thermometer, like the thermometer that they point at the forehead, used infrared to check my temperature.
It can also check your pulse.
Oh, that's true. Very neat.
Infrared's a really cool technology.
It is. And it sounds like there's been a lot of engineers who have used this natural resource and used it to solve everyday problems.
That's right.
Like being able to check a temperature really quickly.
Or check someone's pulse or their pulse ox to figure out how well they're breathing. Or to warm someone up without a heat source.
Conduction.
Ooh.
Like conducting a
Yeah,
symphony
like a band,
or a band.
you know, the conductor.
Okay.
In the band. Or toot toot, the conductor on a rail.
Oh yeah. I was thinking like when they say like how you conduct yourself. How I behave.
How you behave. What do they mean though? Because that doesn't make any
No.
sense.
It's the transmission or transfer of heat, electrical charges, or nervous impulses through a medium.
So it's when heat travels through something else.
Yes.
So like if you, like a coffee cup, I pour my coffee in the cup,
Oh.
and if I have a ceramic mug, I put my hand around the mug and I can feel the warm.
That's because the heat is transferring from the coffee through the mug to your
So that
hand.
ceramic must be a good conduction source for heat. Huh.
Heat travels through the wall by conduction from the warmer side to the cooler side.
It does.
Like in a mug.
Love it.
And convection.
I have a convection oven.
Yes, that's what a roast setting on my oven. That's what I said.
And you know what happens when I have put my roast setting on, my convection? A bunch of fans turn on.
I wonder why.
I don't know. It's just the setting.
And I also notice if I use the convection setting, things cook faster.
Much faster. You have to be very careful. Sometimes I push it on accident and then I burn the dinner.
I've burned a cookie or two. So it's the movement of heat through a liquid or gas because of the rising of heated parts and the lowering of cooler parts.
This happens in weather. Convection happens when there's warm air and cool air colliding. And what happens is it creates clouds, and sometimes if it's unstable, it creates thunderstorms.
Oh, interesting. So then the hot air rises and the cool air
Falls and it
down.
rains or hails and thunder and lightning and electromagnetism, or didn't say that correctly.
Interesting.
Magnetism.
magnetism.
Magneticism. Mrs. Wally. It's been one of those word days for me.
I used convection to bake my cookies.
It cooks much faster and it's tasty.
I
So it-
used convection with some conviction.
I really believe firmly in the convection.
Yes, make
So-
good cookies.
You said that fans turn on.
Yes.
And we know that convection is the movement of heat. So I wonder if those fans are moving
They're pushing the heat around in the oven. Fans don't always cool. Depends on the air temperature.
We have a boogaloo.
Okay,
It's the heat transfer boogaloo.
here we go. We're going to try it.
Catch on with us and do this with us.
I'm a physicist and I'm here to say I study how heat works every day. Sometimes I write a paper, sometimes I read a book, but usually I go out and take a look. Conduction, convection, radiation too, doing the heat transfer boogaloo. Conduction is the transfer of heat through solid material, like when you use a metal pot to heat up your cereal. Metal is a good conductor, air is not. If you leave a spoon in boiling water, it'll get hot. Yes, it does. Conduction, convection, radiation too, doing the heat transfer boogaloo. So true. Have you ever burned your hand on a metal
Yes.
you were cooking with and
Yep.
you accidentally left it in and
Yep.
you were busy with your kids and you went and grabbed it and you're like, "Wah!"
Yep.
Yep.
I've done that. Okay.
Sorry,
Next,
Mr. Kevin.
next part.
Here we go. Convection is the transfer of heat through liquid or gas into the colder objects, the warmer will pass. When you boil a lot of water in a very hot pan, the hottest part of the water rises as fast as it can. Conduction, convection, radiation too, doing the heat transfer boogaloo. Radiation is the transfer of heat through air and spaces,
like when the
Oh,
sun-
can we start that one over?
Yes.
Radiation is the transfer of heat through air and space. Like when the sun heats the earth, it makes it a great place. You can feel the heat when it reaches your skin, but no solid liquid or gas is needed for it to move in. And then you could say conduction, convection, radiation too, doing the heat transfer boogaloo. That's why the sun can burn your skin. It has radiation.
Yes.
Should we do an input chart?
Let's do an input chart.
All right. We're going to talk today about the thermal form of energy known as heat
Whoa.
It's everywhere.
everywhere.
working and moving. So we know what kind of energy is it. If it's moving,
Kinetic
know it's
energy.
kinetic. Heat is atomic motion. Atoms are tiny particles that make up everything all around us. All things hot and cold have energy as their molecules are wiggling. If atoms move slow, things are cold. If they move fast, things are hot. The primary source of heat is the sun. And this is a nuclear reaction.
That's why we have solar flares and solar storms that give us the aurora borealis.
Very interesting. And it has electromagnetic radiation, which is invisible infrared rays.
These are the characteristics of this thermal transfer of heat. Oh, there we go. Oh, I forgot one. I have it stuck in my head.
These waves, as you can see, travel to and heat the Earth.
Okay, they're invisible. Did you say that already?
I did, yeah.
Okay, let me get that done. Did you say they were moving molecules?
I did.
Oh, I missed that part. Sorry,
That's
Miss
okay.
Oslin.
No, it's good to review.
Ooh, there they are, moving around. We just can't see them. They're invisible. And it's a form of kinetic energy. Okay, did we say it has radiation? Yes. She was going faster than
I was
I could
too fast.
write. And it traveled. Now here we are.
Yep.
It travels pew, to the Earth. Okay.
And we feel it by touch. Like when you lay out in the sun, your skin gets hot.
You know, I've noticed in the winter time that if it's a bright sunny day, the air can be really cold. But if the sun is out and I'm wearing a jacket, it'll heat up my jacket and I feel like I'm sweating even though it's really cold outside.
Oh, that's like even though it's cold outside, if it's been sunny, I get in my car
And it's
warm.
You know, you can lay out in the sun and feel it. But if you do that, you need to wear sunscreen so you don't, those infrared rays and that radiation doesn't damage your skin and cause skin cancer. Okay.
So we know that all of this energy, this heat, this thermal energy is moving towards the Earth to heat the Earth. But how do we measure it?
Ooh, that's a really good question. How do we measure it? Well, we use measurement tools.
Because we like to know how hot or cold it is outside, right? Before we leave, so we know
Right.
how to dress.
But we don't just measure outside. We can also measure body heat. Is that one of the things we measure? Is that on there for body heat or is that orange? Ooh, I don't know. It's all in the same
It's not
spot.
on this part. It's not on this part.
Okay.
Yeah. We also have your favorite weather reports that let us know this information.
We do.
Heat is measured in degrees using a thermometer. In the United States, heat is measured using degrees Fahrenheit. That's when you look at the temperature, maybe outside, and it has that little circle and an F. The circle means degrees and the F means Fahrenheit. And it's important to differentiate because in science and in most of the rest of the world, they measure in degrees Celsius.
That's the metric measurement for temperature. So when I go visit my family in Australia, everything's in degrees Celsius. And they say it's 32 degrees. And I would think that that's really cold. But that's like in the 80s. It's actually really warm. What's funny is their summer is our winter, and I say it's 32 degrees, and it's 32 degrees for them, and it's really cold for me, and it's really hot for them. Isn't that funny?
Context is important.
Oh, yeah.
So we measure, again, degrees using a thermometer. And just to give you some context about what do we mean when we say things are hot or cold, the freezing point is 32 degrees Fahrenheit or 0 degrees Celsius.
The boiling point, that means where the convection is happening in the water, that it's happening so fast that the molecules that are moving up and going around and around start to create bubbles within the water.
That's 212 degrees Fahrenheit or 100 degrees Celsius.
Celsius is easier for, it's like 100 degrees to boil, 0 degrees to freeze. It's a lot easier for me to remember.
It's more manageable units.
It
of
really
measurement.
is.
Even at extreme cold temperatures, atoms are still moving. Scientists call no movement absolute zero, but it cannot really happen.
Right.
So all the atoms that are in the air or in our bodies are always moving. Heat is a form of energy that is always working and moving and is everywhere in our lives. So if it's moving, again, we know it is
Kinetic energy. Woo! That was really fun to learn about. Next time, we're going to learn about the sources, how it moves, and how we can use it and work with it to help our economy.
Yes.
Okay, friends.
We're doing some more thinking today about how do different forms of energy influence a region's economy. So today we learned,
Keep going.
I was going to say, today we learned specifically about heat and thermal energy, and we're going to make connections between what we learned about that and what that has to do with the Pacific Northwest economy.
Well, I'm thinking about how we were really worried about all of the dams and the salmon, and how we over on the eastern side of our state, it's really warm and there's a lot of sun. It doesn't rain very often, especially in the summer months. And I know that heat creates wind and solar energy, and maybe we could figure out how to capture that energy and sell that energy instead of the hydroelectric energy from the dam. We could replace it
Very
and
interesting.
then get rid of the dams.
It'll be better for
The fish.
yeah. Do some thinking about what you think you know about energy. Go back to your T-chart that we started a couple lessons ago. See if you need to revise some of your thinking.
You might.
See what new thinking you have and what questions you have, or if we answered any questions.
Yeah.
And you can post some of that on Flipgrid. Also, I want you to think about, why is heat so important to our environment and the economy? We might not have answered that yet,
No.
but we will. Now,
We
if you're
will.
not comfortable posting
That's
your
okay.
new learning on Flipgrid, that's okay. Mr. Kevin has 2 other ways that you can send us your thinking.
That's right, 5th graders. You can heat up your keyboard by typing really quickly TV Classroom at tacoma.k12.wa.us. Or you can always send us something in the mail to the TV Classroom headquarters here at 601 South 8th Street, Tacoma, Washington, 98405.
Awesome. Thank you, Mr. Kevin.
Affirmation. Positive self-talk is so important.
I am valuable.
I am valuable. That means I have worth.
Yep.
I like it.
Maybe even I would say more valuable than the sun.
I am more valuable than the sun. Ooh.
I don't know if we need to add that in, but just for a reference of how valuable you are, that's what I think. It's an opinion.
It's one I share. So I'll take a
right.
deep breath. Say our affirmation.
I am valuable.
Excellent job today, 5th graders. We hope you have a great rest of your day. We look forward to seeing you back here next time in our TV classroom.
Bye, friends.
10 seconds to pick your crewmate. 2. A new timer will appear with an exercise for the crewmate you picked. 3. You will get points for each correct crewmate and exercise you choose. 4. You will get bonus points if you find Maui's hook. 5. If you pick the imposter, you will lose all your points. 6. Use your math skills to see how many points you can get. Good luck.